continue on learning linear equations, and we'll also trying to solve the word problems coming from linear equations. So recall from what we learned in previous class, we have learned that we can, when we have a linear equation, there are expressions, there are different terms, there are variables, constants, and we can add, subtract, or multiply or divide on both sides of the equations. Okay. So we can, when solving the linear equation, we can add and subtract or multiplying or dividing on both sides of the equation. And in order to solve the linear equation, all we want to is really to isolate the unknown variable. Right? Because basically why we want to add or multiply the same amounts on both sides of the equations, all because we want to isolate the unknown variable to one side of the equation, and in order to solve that unknown variable. And then finally, when we solve the unknowns, we can check the answer by plugging back the variables back to the equation to see whether the quantity from left hand side of the equation equals the quantity from the right hand side of the equation. Right, by substitute back into the equation. Right? So maybe just a very simple example. If I have an equation 8t plus 9 equals 65, right? First, just observing this equation, we have the expression on the left hand side, we have constant term 9, we have unknown variable t, so t is the unknown variable that we want to solve. It has a coefficient of 8 in front of t, and on the other side of the equation there's just one constant term, which is 65. So by solving this, we can subtract a 9 on both sides of the equation so that this becomes 0, so that the unknown variable is kind of isolated. This would be this 6, right? And then I can further divide 8 on both sides of the equation. So then the unknown variable t is now fully isolated. So I got t equal to 7, and then finally I can check by substitute this value back to the original equation. I have left hand side equals to 8 times, now I know t equals 7 plus 9, it's 56 plus 9, this is 65, which here, because there's just one single number on the right hand side, I don't need any further calculation, but I can check or I can validate that this is the solution because it makes the equation equals on both sides. Okay, so then coming from here, in today's class, we'll continue seeing some more complicated examples, and eventually we'll link this to some word problems, and we'll learn how to solve the word problems by using linear equations. Okay, so let's start with examples. The first one, let's try to solve 4t minus 7 equals 3 of 2t plus 3. Now, this one, remember we'll also learn the simplification of expressions, Right? So we can first simplify the expressions on both sides of the equation. This is just simply multiplying this number into the brackets. I have 4t minus 4 times 7 is 28. On the other side, I have 3 times 2 is 6. So I have 6t plus 3 times 3 is 9. And then I'm trying to isolate the unknown variables. I have unknown variables here and here. And I have constant terms. So by moving them around, in the first example, I will do it slowly, but essentially you're moving one term around to the other side of the equation, and you're moving the constant term to the other side of the equation. So it's really just moving them around to isolate or to group the unknown variable on one side of the equation. So this time I decide to move all the variables to the right hand of the equation. So I need to kind of eliminate this term from the left hand side, right? So moving this to the right hand side is equivalent to subtract this term or change the sign of this term. So how does this work? Why it equivalent to changing sign? Because I will first minus subtract 4t on both sides of the equation, and what I get will be I'm subtracting a 4t on the left hand side. Equivalently, I will subtract the same quantity 4t on the right hand side. So then this 4t minus 4t are 0. So what I left is minus 28 equals 6t plus 9 minus 4t. I'm not grouping this together yet because I want to demonstrate to you that later on we can quickly doing this moving around the terms. Basically, if you're moving one term to the other side of the equation, it changes the sign, right? 4t disappear here, but 4t appears on the right hand side with a change of sign. Okay, so let me write one more step to group these two similar terms together. Always simplify your expressions after you move in terms. Now I have all the unknown variable t on one side of the equation, but I still have constants on both sides. I want to move this number over here to the left hand side. So you can imagine that this 9 will be moving over there and becomes minus 9. So again, let's do this step by step. This, I want to cancel out this term, right? So which means I want to subtract 9 on this side, and then to be consistent, I should subtract the same quantity on the other side. So which means I'm subtracting 9 on both sides of this equation such that these two are just canceled out to be 0. And then here I will have minus 28 minus 9 is 2t, right? Again, if you compare to the expression before we're doing this, the number 9 is kind of moved to the other side of the equation with a change sign. Okay, further simplify this will give you minus 37 equals 2t, and then I'm dividing a 2 on both sides of the equation. I will have minus 37 over 2 is t, and I'm just rewriting this because usually by the end we always want to write the unknown variable on the left-hand side of the equation. I mean, this is just simply equivalent between each other. It's just in most of the cases, people like to write the variable on the left-hand side of the equation and write their answer or solution write the unknown variable on the left-hand side of the equation and then write the solution on the right-hand side. So up to here, we have solved this, but always do the last check step. So let's check if this is really true. So I have the left-hand side of the equation is 4 times t minus 7, where I have solved this t as minus 37 over 2. So I need to combine this number together, which means I need to find the common denominator. Remember what we learned in fraction. we need a common denominator, so this will be 37, and if I have a denominator of 2, this will becomes 2 times 7, so it's 14. Right, so this is a 4 times minus 451 over 2, so it's minus 4 divided by 2 is 2, so it's minus 2 times 51, so it's minus 102. Okay, so then to check right hand side, I have 3, so the right hand side I have 3, 2t plus 3, which is 3 times t is this, so 2t, 2 times t is minus 37, plus 3, I have 3 times this minus 34, and then 3 times minus 34 is 912 minus 102. So it's minus 102 on left hand side and minus 102 on right hand side, so they are equal to each other. So yes, so this is the solution. I've been checked that. Right, so what we have learned from this previous example, so in this example we have a bit more complicated situation that we have the unknown variable t on both sides of the equation. So if the variable appears on both sides, then we can use addition or subtraction to get them on the same side. Right, I'm using subtraction in this specific example. I'm using subtraction to moving around the constant term and the variable terms, in eventually making sure that all the constant terms are on one side of the equation and all the variable term on the other side of the equation. And also, if you don't like the fractions, even though in this example we don't have fraction yet, but we'll shortly see one example that contains fractions. So if you don't like fractions, you can eliminate the fraction by multiplying the common multiple on both sides. So eliminate fractions by multiplying a common factor or common multiple on both sides of the equation. Okay, so let's see an example on how can we do that. So if we have 9 over 4 minus 2x over 3 equals 6x over 5, 7 over 3. Now we have another equation. We always observe your equation or expression before you start solving that, just to have a general idea that what I'm going to do next. So I see that here the unknown variable is expressed as the term of x. I have constant terms, I have unknown, I have variable terms. They all spread on both sides of the equation. And I also notice that there are fractions. In fact, all the numbers are fractions in this example, but at least they are are fractions. So one way that you can still just solve this equation the same way we did over there by moving around the terms by subtracting or adding the same value and then eventually solve the equation, that also fine. You will find the solution, but in this case, there seems to be an easier way that to eliminate the denominators first. Now you see that on the denominator I have number of 5, I have number of 3, so a common multiple. I don't have to have the least common multiple, but at least I have a common multiple will eliminate all the fractions. So the common multiple could be 5 times 3, which is 15, right? If I'm multiplying 15 on both sides of the equation, it will cancel out or eliminate all the denominators and converting all the fractions into numbers. So let's do this. So multiplying 15 on both sides, I will get 15 times this gives you 3 times 9, because 5 cancelled out with this 5. And 15 times this will be 5 times 2x. 15 times this will give you 3. I'm going to use dot instead, because in this equation we have x, which is easily could be mixed with multiple sign. Just be very careful that you can either use multiple sign or you can use a dot. You can use whatever way to represent your operation, but be very careful that don't mix the multiple sign with x, or don't mix the dot production with the decimal numbers. Just be very careful in your writing. So now I can simplify. Further simplify these, I will have 27 minus 10x, 18x plus 105. Now I can start moving around these numbers as usual, as how I solved the example over there. So I might doing this a bit quick. So 105, let me decide to move all the variables on the right hand side and then move all the constant to the left hand side. So 27 has no change. This 105 will be moved over here, so then change sign becomes minus 105. Similarly, 18x stays the same, but this minus 10x will be moved over here, becomes plus 10x. For clarification, I was still going to write over here this equivalent to subtract 105 on both sides and plus 10x on both sides. You can try this by yourself on the scratching paper as well. You should get the same output like this. Okay, so then 15, yeah, let's see. So I'm multiplying 15 over here. This should be 5, because 15 divided by 3 has 5 left, so it should be 5 times 7. So this number really should be 5 times 7, which is 35. So I'm subtracting this 35 to the left hand side. Right, so it's there's a small correction on the number. So then 27 minus 35 will give you minus 8, and on the other side it's 28x. So now I'm just dividing the 28 on both sides to finally isolate x, and I'm going to write x on the left hand side, but it's equivalent. So x will be minus 8 over 28. Further, to factor out, apparently number 4 is a common factor, so divided by 4 I will get minus 2 over 7. There seems no further simplifications, so the final answer is minus 2 over 7. Okay, so I will leave for your own practice that first you can try to solve this equation without canceling out the denominator. You can just solving this by moving the fraction constants to the left hand side and then having the unknown variable on the other side, and then by combining this you can still use common denominator to have this equals to that, right? You can combine these two terms and eventually you're still able to solve x from here, so you should get the same results. And I'm also going to leave for your own practice that you can then perform the checking step by plugging or substitute back your solution to the original equation to check if the right hand side equals left hand side. Okay, so we'll see one more example. Okay, in the next example, let's try another equation with fractions. This time I have 3x plus 4 over 5 is 2x minus 8 over 7. So similarly, what I can do is to find the common multiple that apparently can be 5 times 7, which is 35. So I can multiplying the 35 on both sides of the equation, I will get 7 times this equal to, let me just write it down. Multiplying this will give me 7, 4 is here, 35 divided by 7 is 5, so 5 times this. Now, you probably find that this is just equivalent to when you're operating this by cross the values or the terms as the productions, right? So this actually equivalent to you to perform the same common multiple, to multiplying the common multiple on both sides of the equation. But to simplify the step, you can understand this or memorize this as a cross production. So basically, if I have any form of A over B equals C over D, this can be converted as or equivalent to A D equals B C, basically cross production or cross multiplication, converting fraction into non-fraction equation. So if I continue from here, I will get 21x plus 28 equals 10x minus 40. I'm moving 10x over here, so 21 minus 10 will have 11x. I'm moving 28 over there, minus 40 minus 28. So my 11x equals minus 68. So then my x is minus 68 over 11. So I solve x from here in this way. So be careful that I'm just showing this as a trick that you can easily converting the fractions into non-fraction equation, but this only works if on both sides you have one complete fraction as a over b and c over d. If you have some other terms over there, then you cannot use this way. So this only works with two single fractions on both sides of the equation, right? If this is not two single fractions, you cannot do this. For example, if I have 4 minus 7t over 6 is t over 8 plus 2. This time it's not equal to equivalent to 6t equal to 8 times that, because I have a plus 2 over here. I cannot just drop that. So I have no choice, but I still need to use the regular way to do this. So this means I need to multiply common multiple. 6 times 8 is 48. So 48 is at least one common multiple that I can use to multiply on both sides. So basically, this is just the regular way that to simplify fractions. So let's do this quickly. So I have 6t plus 48 times 2. So I have 32 minus 56t is 6t plus 96. So further simplifying this, I have moving t over there to get the positive coefficient. So minus 96 will become on the left hand side. Have 6t plus 56t. So I have minus 64 equals 56 plus 6 to t. So t is dividing by 62. So it's minus 64 over 62. Looks like I can simplify this by at least dividing by 2. I have 32 over 31. Now 31 is a prime number, so there's no further simplification. So the solution to this is minus 32 over 31. As usual, I will leave the check step for you to practice. Okay, we've been seeing several examples so far. We can always use those techniques that we learned to solve the unknown variable from one equation. But does that true that every equation has a solution? It's not always true. So let's see one example. So suppose I have 5w plus 3 minus 2w equals w minus 8 plus 2w minus 3. Let's try to solve this one. So again, the first step to observe that I have my unknown variable written as w. I have all others as constant terms. So let me simplify the expression first by combining the similar terms. So 5 minus 2, I have 3w plus 3, and I have 3w minus 11. And if I'm trying to moving around the unknown at one side, I should move 3w over there. It becomes minus 3w. Or you already see that I have 3w's on both sides of the equation. They can be cancelled out. Then I'm ending up with 3 equals minus 11. Apparently 3 does not equal to minus 11. So if you ever end up from a equation that ending up with an equation that can never be true, this means this equation has no solution. No solution means no matter what value that you take for w, you always end up with 3 equals minus 11, which is not true. So which means there's no such value for w that can satisfy this equation. So it's always no solution. So let's write this down. So if you end with two different constants, must be constants, because constants, you know that for sure they're not equal. Right? So two different constants on either side of the equation. this means this equation has no solution. Right? So basically this means this type of equation has no solution. Okay, so we have seen one example that shows that there could be scenarios that no solution can be found for the equation. Now there's one more special case of the equation. Let's see this example. I have 2 that minus 8 minus 5 that is equals 2 minus 3 minus 10. Okay, again, observing that that is my unknown variable, I need also to group the similar terms to simplify the equation first. So I have minus 3 that minus 8 is 2 minus 3 that 2 minus 10 minus 8. Then these two terms are the same. These two terms are the same, which means if I'm moving this to left hand side and moving that to the right hand side, equivalent to plus 3 that on both sides and plus 8 on both sides, I will get minus 3 plus 3 that equals minus 8 plus 8. And then this 2 becomes 0, this 2 becomes 0. I end up with 0 equals 0. Right, so that means, again, no matter what value I put into that, this equation is always true. Like for example, because they cancel out eventually, so which means if I say that equal to 1, this is true. If that equals to 10, this is also true. So that can take any possible value, and this equation is always true. So this means I have infinite many solutions to this equation. So this means if you now end up with 0 equal to 0 or a constant equal constant, then this means all possible values of the variable are solutions to this equation. And so this means all possible values of the variable are the solutions to this question. So this means you will get infinite many solutions to this equation. Okay, having been seeing this many examples, there is one more thing before we move into solving the word problem. There is one more thing that is very important, and you should avoiding that is do not multiply zeros on both sides. Okay, why? Because first of all, multiplying and dividing or adding or subtracting on both sides of equations are reversible. Basically, if you can adding numbers, which means you can also subtracting numbers. If you can multiplying that number, that means you can also dividing that number. But apparently, mathematically, we cannot divide by 0. Right? So that means you can also cannot multiplying a zero. So apparently you cannot divide a zero on both sides of the equation, but at the same time you cannot multiply a zero on both sides of the equation, right? So, and the reason why, or the examples can easily show why we cannot do that. We can just use this for example. This equation we prove that there's no solution because we end up with 3 equal to minus 11. But if I'm multiplying a zero on both sides of this equation, I will get 3 times 0 is this times 0. And I'll get 0 equal to 0. Then 0 equals 0 means I have infinite many solutions instead of no solutions here. And this you can see that 0 cancels out anything. Another example, if I'm having x plus 2 equals 4, this very simple equation, I can solve from here that x is actually equals 2, right? 2 plus 2 equals 4. So I can solve this easily by getting x equals to 2. But if I'm not stopping here, if I choose to multiply a 0 on both sides of the equation, I will get 0 multiplying this equals 0 multiplying this. I'll get 0 equal to 0. Then this means there looks to have infinite many solutions, not just one solution. So this apparently is wrong. This is also wrong. This just because we cannot divide it by 0. And same thing, we cannot multiplying a 0 on both sides of the equation because 0 just simply canceled out, removed everything. So canceled out all the terms means it's removing all the information. And by removing the information, you will not be able to use such information to solve your equation. So it's like your question has been wiped out. So I'm repeating this just because this is very important that when you're trying to solve your linear equation, when you're operating with adding or subtracting or multiplying, dividing numbers on both sides of the equation, be very careful that do not multiplying 0. Okay, in the next part, let's going to see some word problems, and we'll see how can we solve the word problems by using equations or by using linear equations. So couple of the things that you may want to know before you start solving the word problem. So first of all, read the problem carefully. Right, read carefully, because if you read the problem in the wrong way, then you will get your equation or your expression wrong at the very beginning. Then it doesn't matter how you're going to solve it in the later step, it's just a waste of time. So always making sure that you read your problem carefully and to have the right mathematical expression for that. Otherwise, it's just a waste of the time. Now, after reading the problem carefully, then you will need to convert your problem into a mathematical equation. Right? Convert to math or convert to a equation. And we'll see more on this step, because when converting into equations, you need to looking for the equivalent quantity to kind of construct the equation. Right? So then once you are able to convert your problem into an equation, then just solve the equation and then convert your answer back to Word. So solve the equation and convert your answer back to words. And finally, as always, once you solve your equation, you will need to check your answer. Here, we'll probably show that you can check your answer either by still using the equation, or you can also check your answer by directly putting back to the word problem and checking it verbally. Okay, so let's start seeing some examples about word problem. The first one, when you add 12 to a number, and then you divide the sum by 13, you get the same result as when you subtract 13 from the number. And then divide the difference by 12. So what is that number? So let's read this again. So I have a number, and if I add 12 to that number and divide the sum by 13, I get the same results as when I subtract 13 from that number and divide the difference by 12. So first of all, I have two statements or two expressions or two sentences. So which means I can convert each into a expression. And then I have a condition that I get the keyword same results. This indicates that I can construct a equation based on that. So how to do this? So first, I have one expression. Let me quote from here. Quotation number 1. From this statement, I'll get one expression that will let this number. First, we need to assign a variable to the unknown. Let this number to be x. So this is the unknown that we want to solve. Again, later on, you will also see examples that sometimes you will try to just make the unknown variable, make the unknown quantity as the variable. But sometimes it's not that direct, so you may also assign a indirect quantity to your unknown variable. It depends on the question. So this question seems straightforward. I'm just letting this unknown number as x. So the first statements give me, if I'm adding 12 to this number x and divide the sum by 13, I'll get the first expression, right? Now the second expression is here. When you subtract 13 from this number, so it's x minus 13, and then divide the difference by 12. This difference divided by 12. So I have two expressions from this word problem. And how do I construct the equation? I also got the statement saying that I should get the same results from these two. So which means they should equal to each other. So then I have 12 plus x over 13 equals x minus 13 over 12. So this is my equation that I got from this word problem. And then all I need is to, so I already convert this into a mathematical equation. Now I'm just need to solve that. So I'm going to do this a bit quicker. We saw this example before that there's two single fractions on both sides of the equation, you can just cross dot the numbers. So I got 12 times 12 plus x is 13 times x minus 13. I have 144 plus 12x is 13x minus 169. Right, moving this around, I have 144 plus 169 is 13x minus 12x, which is just x. So going this way, I have x is this plus that, which is 303. Sorry, 313. 6 plus 4. This is 13. This is 0. So 313. So this is how I solve the equation. I got my x equal to 313. So lastly, I need to check my answer. So first of all, I will leave this to you, that you can either check it by directly substitute back to this equation. I'm pretty sure that you will find the left-hand side and right-hand side, and you will see that they are equivalent to each other. But here, as an example, I'm going to check my answer directly back to the word problem. So the first sentence or the first statement saying that I'm adding 12 to this number 313, I got 3, 3, 5, and then, sorry, 3, 2, 5, and then I'm dividing this sum by 13. I will get, actually I will get 25. Okay, so check with the other. Subtract 13 from this number, I get 313. Subtract 13 from this, I get 300. And then when dividing the difference by 12, I got 25. So I got the same results, and they are having the same results. So this to check that my solution is correct. So eventually my answer, converting back to word, is that this number is 313. Okay, so let's see the next example. Let's see the next example. So in this example, my sister and I are going to buy a TV. Because I am older, so I will promise that I pay $45 more than my sister. Now, if the TV cost in total $299, how much does my sister pay? Or how much do I pay, or how much does my sister pay? So here, if you looking at this example, you will find that there's two terms are unknown, which is how much do I pay and how much does my sister pay. I don't know either of them. I only know that totally we pay $299 and I paid $45 more than my sister. So this means we have more than one thing unknown. So how do we solve this in one linear equation? So first of all, we can still choose one of the unknown to assign the variable to that. In fact, you will find out that doesn't matter which one you're using, you will also always get the same solution. In this case, let me assign my sister to be the unknown quantity x. You can try later in an alternative way, and you will find out they are equivalent. So here first I assume that my sister will pay x dollars. Then how much do I pay? I promise to pay $45 more than my sister pays. So if my sister pays x, I will pay x plus 45. right? And then in this case, how can we, so we have two expressions representing two different quantities. So how do we form a equation? How do we build the equation to solve that? What is the equivalent quantity we can find? So the equivalent quantity, or the quantity that we can find, is the total TV cost, because total TV cost is what we pay together. Basically, the money I paid plus the money my sister paid is equivalent to the total cost of TV. So x plus x plus 45 from both of us should pay the total amount of the TV, which is 299, right? So then we have one unknown variable, and we have we have construct a equation that coming from this word problem, coming from the equivalent quantity. So now the next step is to solve this equation. We can simplify it first. It's 2x plus 45 equals 299. So moving 45 over there, 299 minus 45. So the 2x is 254. X will be 254 divided by 2 is 127. So my sister pays $127 buying this TV. So let's check if this solution is correct. If my sister pays 127, this means I'm going to pay $45 more than that. So I'm going to pay $172 if I'm going to pay $45 more than my sister. So let's then sum them together to see if that's really the total amounts. 299, so 299. It is exactly the total amount that we paid for this TV. So I'm validated that this is the solution. Okay, so here I'm not showing the complete steps, but I'm going to show you a alternative way. As I said at the beginning, sometimes there's no unique way to assign the unknown variables. You could have many different alternative ways, but by the end you will always get the same solution because it's the same equation, it's the same quantity that making them equivalent. So for example, this time if I decide to assign the unknown, let's say y, to me, so assume I pay y dollars for buying this TV, then my sister should pay y minus 45, right? And then if you add them together, let this equal to the total cost of the TV, you will be able to solve y from this equation, this new equation. And then if you solve the y, then my payment is y, then my sister's payment is y minus 45, and y minus 45 will be the answer to this question. And hopefully you should get the same quantity as 127 over here. And then you should also be able to check this results by putting them back into the word problem. So I will leave the details for you to practice, but you should get the same answer compared to the first option. So this is just to show you that sometimes there's no unique way to assign the unknown variable, but they should always give you the same answer to the problem, because there should be only one unique answer to the problem. Okay, Let's see the next example. So in this example, I bought a new book from the bookstore, and if I'm paying this book entirely using quarters, I can do that. But if I choose to choose to pay this book by using dimes, then I would need 9 more coins to pay this book. And this question is asking how much is the book. So let's maybe write a bit more details from what we learned from this word problem. So first of all, if I'm paying by quarters, right? Quarters are 25 cents, right? I need some coins, some quarters to pay that. I can pay this entirely using quarters only. So this is one option. Second option, if I instead paying that by dimes, so dimes are 5 cents. Yes, I can also choose to pay that by using 5 cents dimes. But then I would need 9 more coins comparing by using quarters only. Now you see the relationship, right? And then each of them will give you the total cost of the book. Right, so now writing in this way, you probably already see the equivalent quantity that for you to construct the equation that is the cost of the book. That is kind of clear. But then how do I assign the unknown variable? So this time looks like the cost of the book is not a good choice to assign the unknown variable, right? Because this, I still don't know how many coins are in option 1. I don't know how many coins are in option number 2. Even though I can let the cost of the book equal to x, it doesn't help me to build this equation. So this means sometimes we need, alternatively, we can use, if there's no direct value that can be assigned to the cost of the book, we can assign the variable indirectly. So assign this in an indirect way. So alternatively, there's one quantity that I can think about that I can use is the number of coins, right? Even though I don't know the number of coins in either option, but I know that the second option needs 9 more coins. So again, similarly, I can either assign my unknown variable to the number of coins in the first option, or I can assign to the second option. Again, similar to the previous example, you should get the same results. But over here, for simplicity, let me assign x to be number of coins by using quarters only. By using quarters only. Then this becomes x. So then in the first option, I have x coins. In the second option, I have x plus 9 coins, right? So I can now write out the number of coins in either option. Then how do I construct the equation? The equivalent quantity is the cost of the book. So either of them should equivalent to the total cost of the book. So that helps us to build the equation. So in the option 1, the cost is I have x coins. I have each coin values 25 cents. So that's the total cost. In the second option, I have x plus 9 coins. Each coin values 5 cents. And by using either option, they should all equals to the cost of the book. So which means 25x is equivalent to 5 times x plus 9. Now this is how I convert this into a equation. And then the next step is just solving this equation. We'll do this quickly. So this 5x plus 45, moving 5x over there, 20x. Oh, actually, 1 dime means 10 cents. It's not 5 cents. Okay, so it's 10 cents, so it's times 10. Otherwise, we'll not get an integer number, but number of coins should be a integer. So it's 10 times, so 10x plus 90. Right, so then I'm moving 10x over there, 25 minus 10 give me 15. And then 90, there's only one constant term 90. So then 90 divided by 15 is 6. Right, so I have 6, I need to use 6 coins in option 1, or instead I would need 6 plus 9, which is 15 coins in option 2. Right, and we can check that. So first of all, if by using quarters only, I need 6 coins. Each coin values 25 cents, which means I need totally 90 cents for the cost of the book. Or option 2 means I need 6 times 25 is 12 by 30 is 150 cents for the book. Or alternatively, in this option, I need 15 coins. Each coin values 10 cents, so it's also 150 cents for the book. So this validating that my solution is correct when plugging back to the word problem.